So as mentioned, I'm Beth Stys. I'm with the U.S. Fish and Wildlife Service at the Southeast region with the Science Applications and Migratory Bird Program. So if we could go ahead and start to go to the next slide. The Florida's geographic position and latitudinal range mean that the state is situated such that it encompasses both the temperate and subtropical climate regimes, as Mike already covered a little bit earlier. The ability of Florida's ecosystems to support plants and animals is intimately tied to those geologic, hydrologic, and climate variables, as Lori even mentioned just in her presentation. These things including the timing and amount of precipitation, water chemistry, the frequency and intensity of storms, and the range and duration of temperature extremes all help support the diversity of plants and animals. So the interactions of those factors over time have led to the state's unique biota, creating our region with extremely rich biodiversity and containing a multitude of unique systems. Next slide, please. So climate change impacts on these species will be driven by one or multiple climate-related factors, acting synergistically with each other, as well as with existing non-climate stressors. These ecosystems and species of Florida have adapted to past periods of climate change. However, ecosystems are now under more stress and are less resilient due to human-caused alterations. The impacts of climate change on species and these natural communities are greatly magnified by the decreased adaptive capacity due to these habitat loss and degradation associated with things like land use change, invasive species, and diseases and pests. So the Florida's biodiversity of the future may be very different than what we have now, with some species and ecosystems being affected to a greater extent than others. Next slide, please. So climate change will have impacts on biodiversity that operate at the individual, the population, community, and ecosystem scales, altering things like species distributions, their life histories, community composition, and ecosystem functions. The species that are most vulnerable to impacts from climate change are those that have things like poor dispersibility, slower growth rates and lower reproductive rates, more narrow environmental tolerances and those triggers and thresholds that we heard about earlier, and those that are habitat specialists, among a lot of other traits. But species like the black rail will lose their critical coastal habitat to inundation from sea level rise. That high marsh habitat that they use is likely to get squeezed out between the low marsh moving inland and the inability of the high marsh to migrate inland due to natural and human-built barriers. Beach nesting birds will likely experience habitat degradation as their nesting and foraging areas are impacted by increased storm events that will cause flooding and erosion, as well as due to inundation due to sea level rise. Changes in precipitation patterns could lead to altered community dynamics. For example, ephemeral wetland amphibians will be impacted if precipitation changes lead to flooding events that then connect those isolated wetlands with other wetland systems, introducing predatory fish. Species such as the Florida sandhill crane may see reduced reproductive success with altered precipitation patterns. When the timing and amount of precipitation leads to flooding of their nests or significant drying of those wetlands leads to nest failure due to increased predation by terrestrial species. As mentioned before, we're already seeing impacts of climate change due to temperature increases and altered water chemistry on species, including keystone species such as the corals and coral reefs. Climate change is also expected to exacerbate impacts from non-native species. It's also been mentioned earlier, but climate change can facilitate the introduction of new invasive species by increasing the rate of spread and competitiveness of those species. And on a more management side of things and disturbance regimes, the ability to maintain the fire-dependent systems throughout Florida through the use of prescribed fire will become more challenging with increased temperatures, changes in precipitation, and the increased number and intensity of storm events. Next slide, please. So we tend to talk about these changes in the future, but we're already seeing impacts, and we're already seeing species and systems respond to impacts from climate change. Species are shifting their ranges in response to warming temperatures. We've already heard about how mangroves are moving northward. Other species, such as snow flounder, are also moving northward. Species are already experiencing physiological effects. Sea turtles are having higher percentages of female hatchlings as warmer temperatures are affecting their hatchling sex ratios. We're also already seeing phenological responses to climate change. Migratory birds are shifting the timing and patterns of their migrations. Pest species, such as the southern pine beetle, are increasing the number of generations within a season, which increases the detrimental effects on the pine forests and on those species that depend upon them. As previously mentioned, we're seeing increased catastrophic wildfires fed by increasing temperatures, decreased precipitation, and increased fuel. And we're seeing an increase in ghost forests along Florida's coast. These ghost forests that consist of dead and dying trees due to increased salinity and inundation. But this type of system change, where one system may lose out, while another one may benefit. The reduction of coastal forests may allow for easier inland migration of systems such as salt marsh, or as Mike was talking about, there may be make it easier for migration of mangroves. Next slide. So something to always consider when you think about how species and plants are going to respond is how humans are responding as well. In the past, as mentioned, Florida species have migrated and adapted to climate change. However, the ability of species and systems to adapt now is further challenged and severely compromised due to human modifications of the landscape. Shifting patterns of human habitation to accommodate movement away from the coast as they become more inhospitable due to sea level rise will lead to loss and degradation of inland habitats. Man-made ecosystem alterations put in place in response to climate change may lead to increased habitat loss, degradation, and fragmentation. For example, the use of hardened shoreline stabilization measures, as pictured here in the middle picture, coupled with, say, more intense storms will lead to loss of coastal habitats, and they already are. So it's, again, not necessarily in the future. Land use changes leading to additional habitat fragmentation will hinder movements of species, further reducing their ability to shift their distributions in response to climate change. Next slide, please. So there are a lot of challenges. And even though we are able to detect and track some responses to climate change, we still know very little on how species and systems will respond. There will likely be many surprises in our future. Some species may be more adaptive than we expect or adapt in ways that we didn't predict. There may also be species that are more sensitive to changes and decline at unexpected rates. Biodiversity conservation in a changing climate requires a reevaluation of our management goals and objectives. And this can be a really difficult process to acknowledge that the way we've always done something or are currently doing something may not be the best path forward. Management approaches will need to be proactive and forward-looking, focusing on maintaining a diversity of well-functioning ecosystems. It may be very difficult, if not impossible, to maintain the historical or even the current spatial arrangements and composition of species. Again, this can be very difficult. It may mean a refocusing on what our priorities are and how we go about managing for them. As mentioned previously, climate change will have impacts across all scales. Climate change will lead to ecological transformations across very broad scales, but will also have very localized impacts. The adaptation strategies that are often developed regionally for a landscape scale stressor need to be implemented locally. And that's a dynamic that is and will be very challenging. Monitoring is already difficult, and given these shifting baselines, monitoring will be even more important. And there are even more things and more variables that will need to be measured and monitored, creating, again, even more challenges. Additionally, there's also some uncertainty still of, what do we need to measure and how often? So it'll be integral to adaptation effectiveness that an element of flexibility and acceptance of uncertainty is acknowledged and accepted. Next slide, please. Luckily, this isn't all doom and gloom, so I'm going to go on the positive side. There are a lot of opportunities right now. There's been a lot of success with implementation of nature-based solutions, things such as living shorelines. There's an increasing number of opportunities for partnerships and funding at national, regional, and local levels. And as awareness continues to grow on the importance of how we respond to climate change and what we implement in human responses and for nature, there's a more informed and active citizenry to engage. Some of the most important management options that we have are ones that we already understand and prioritize. We should continue to focus on reducing these non-climate stressors, to continue to implement and support best practice strategies, creating more resilient species and systems. The recently passed Florida Wildlife Corridor Act will greatly enhance our ability to continue to work on a connected network of lands and waters, one that is resilient to climate change. And there's a need to be creative and identify and develop new solutions and strategies. This is our opportunity to think outside the box and be innovative. Next slide, please. I wanted to quickly share some examples of ongoing adaptation strategy evaluations. In response to increasing temperature and impacts on sex ratios of sea turtle hatchlings, various nest shading techniques have been evaluated. In one study, they tested cloth, sand, and palm fronds, and they found that the palm fronds produced the best nest temperature reductions. Other coastal studies have evaluated ways to provide alternative nest sites for marsh and beach nesting birds. Some have tested floating nest platforms, while others have provided elevated nesting platforms that I think somebody asked about in one of the last question sessions. Both of these type of things address degradation and habitat loss of nesting sites due to erosion from storms and inundation from sea level rise. There also has been a study testing the applicability of pond liners for ephemeral wetlands with the intent of maintaining appropriate hydrologic conditions when experiencing reduced or altered precipitation patterns. But this is not just a comprehensive, next slide, sorry. So this is not a comprehensive list or priorities list of needs, but just some issues that have repeatedly come up. We need to document both successes and failures of our adaptation actions and share these lessons with each other. We're all working under these changing conditions, so making sure that we work together and learn from each other will increase our success. We need more information on the economics of adaptation strategies. There's also this often overlooked cost of inaction. Having a way to assess the economics of adaptation will aid in decision-making processes. And there's a lot we need to learn about species thresholds and these trigger and tipping points. From Mike's presentation, you can see it is really easy to see how useful this type of information can be. We need to reevaluate the definitions of non-native and invasive. And this, again, I think came up in one of the other questions. Some species that currently considered only transient or occasional may expand or shift their range more permanently. And as I think the question was asking, we may need to reevaluate, native species that may become more of a native invasive due to climate change. Next slide, please. So there are a lot of resources out there that provide guidance on incorporating climate change adaptation strategies into conservation planning and management actions. These range from national level down to state level. The Association of Fish and Wildlife Agencies has developed several climate change guidance documents, and the Department of Interior and the U.S. Fish and Wildlife Service have produced several guidance documents, both having their climate action plans released just this past October. Next slide, please. So a quick mention of the Fish and Wildlife Service Climate Change Action Program, or CCAP. The CCAP has 7 key elements that include actions that identify ways to maximize adaptation, resilience, and mitigation potential of conservation actions. And again, I think someone was asking about, the CO2 and mitigation actions. It does build on a strong science foundation within the service. It will be a cross-programmatic effort with ongoing work right now to step down that national plan to the Fish and Wildlife Services regions. Next slide. So stepping down a little bit more now, down to Florida-specific information, the Fish and Wildlife Conservation Commission, working with the U.S. Fish and Wildlife Service, developed this online Climate Adaptation Explorer for Florida. The Climate Adaptation Explorer provides a starting point to address the predicted impacts of climate change on Florida's fish, wildlife, and ecosystems. Next slide. And so the last slide to wrap up, just one quick last bit on how the service is working to incorporate climate change adaptation into service programs, processes, and projects. The service is currently working on in-reach to staff on the Resist, Accept, Direct, or RAD framework. The RAD framework will provide a way to respond to ecological transformations. It provides a portfolio of options applied across the landscape to respond to those ecological transformations for the purpose of fish and wildlife management. That should be it. Next slide. Okay. We'll try. All right, so would it be beneficial to assist the upward movement of species, flora and fauna, and why? So I don't know if that's referring to the A part of the RAD framework in the assist, but yes, that's why it's there as an option. And I think the framework will help managers decide, if assist is the most appropriate action. There's examples of, you may want to resist for in the near term and then move more toward the assist or direct. So, well, I guess the A in RAD is accept. Assist would be more of the direct. Sorry, wrong letters. So assist is direct in that RAD. So yes, it may be very useful to assist because by restoring natural functions, restoring more natural hydrologic systems, that could be an assist for species that otherwise may not be able to migrate in, but that little bit of assist in restoring or removing barriers or implementing underpasses, overpasses to allow species to shift could be all they need to do to persist more long term. So what can be done as far as urban green spaces, parks, medians to assist with adaptation and resilience? I think more of them. I mean, the simple answer would be yes, more green spaces would be great. There's a lot of wildlife can use green spaces in urban areas. Pollinators are a good example. Stopovers for birds and migratory species. Even, green spaces could have, wetlands embedded. I think that any type of green space we can incorporate is great. Who will be responsible for abandoned properties and their potential pollution sources as we move inland? Well, that's a funny question. I had that in my presentation, but due to time, I was cutting things out. But on my human responses slide, I did have the abandoned septic tanks and gas stations with the very gas tanks, that those will be an issue as we abandon coastal areas and move inland. As far as who will be responsible for them, I don't feel qualified or don't even know the answer to that, but that is a very good question. And it's one that we need to be thinking about as those shifts inland are happening, that we can't just pick up and move ourselves and leave behind a lot of infrastructure type of things that can cause degradation of the systems. Tell me when I need to stop, Jennifer. I'm going to keep going to you. Am I at time?
Yes, you do, if you'd like to answer a couple more.
Okay. So what ecosystems in South Florida are most susceptible to climate change? I think some of our other presentations have talked about that. Low-lying areas, the Keys, they're islands, they're getting sea level rise from all sides. You have things, the Everglades, very flat, low topography with sea level rise. Storm events. I think, some of the things we don't think about as much is the ability to continue to be able to manage. I mentioned, prescribed fire, but as Florida's population increases, as we move from coastal to inland, those areas of, fire maintained systems are becoming, islands in of themselves of natural systems. The pine rocklands are a great example over a little further, near Miami and somewhat in the Keys, that fire is important, but it's incredibly difficult to put fire and very costly to implement prescribed fire to maintain those systems. And it's going to get even more difficult with climate change.